Hello, in this section I will talk about rectangular coordinate system. So in this figure you can see here we have this coordinate system here. This is x-axis and this is y-axis and this is z-axis. So firstly we will try to locate the point in three directional space. To locate a point we require certain references with respect to which the exact location and position has to be calculated. So rectangular coordinate system is also known as Cartesian coordinate system. So in rectangular coordinate system there are three axes represented by x and y and z, and they are mutually perpendicular to each other, or you can say orthogonal to each other. So here x-axis is perpendicular to y and y is perpendicular to z-axis and z is perpendicular to x-axis. So they are mutually perpendicular to each other. So the references are, you can say here, this is z-axis and this is y and this is x-axis. So this is positive x-axis, this is positive y-axis, and this is axis in positive z direction. So if I extend this axis, it will be minus x-axis, and if I extend in y, this axis will be minus y-axis, and if I extend it in z, that will be minus z-axis. So these actually we have the references plane, xy plane, yz plane, and xy. Here we have xy plane, yz plane, and xz plane, xy, yz, and xz plane. So these three planes intersect in a single point. You can easily understand what is the Cartesian coordinate system. So here we have three planes. You can see here in green, this is xy plane. If you can see here, sorry, in yellow color, this is x and xy plane. If I talk about green one, this is yz plane, and if I talk about this orange plane, this is xz plane. So we have these three planes, xy, yz and xz, and their intersection of these three planes is here. This is the point is P, where we are locating that point, and it is x naught, y naught, and z naught. We have to calculate this point of the intersection of these three planes. So here you can see that the intersection of these three planes is denoted by P. So point P has covered a distance along these x-axis, along y-axis, and along z-axis. You can see here. Here the point we are locating in three directional space with respect to the references here. This point is 3, 4, and 5. So in x-axis this is 3, in y-axis, this is y-axis basically, so it is y equal to 4, and this is perpendicular to here, so this is z-axis, this is 5. So you can see here, this is when we draw a perpendicular here, so we just joined this line here and this line here, so these lines are parallel, so y equal to 4, y equal to 4, and these lines are parallel here, so x equal to 3, that is 3, and this line is parallel, so z equal to 5 or equal to 5. So the position vector rp, if you want to calculate, so define as directed distance from the origin O to P. So you can calculate here 3 minus 0, 4 minus 0, 5 minus 0. As we have already understand how to calculate the distance in vector analysis. So here it is rp equal to op x ax y ay plus z az. So here is the limit x greater than minus infinity to infinity, y minus infinity to plus infinity, z minus infinity to plus infinity. Same here, as I have drawn this axis, this is z, this is x, and this is y. So as I already told you that this is plus to minus, that is minus infinity to plus infinity in x-axis, and in y minus infinity to plus infinity, and in z minus infinity to plus infinity. So a vector A in a Cartesian, otherwise known as rectangular coordinate systems, you can be written it as ax, ay, az. So you can write it as ax plus ay plus az. So this is the representation of Cartesian coordinate system.